Hello class, this is Mr. Eggleston, and this is the CYU for solving quadratics using symmetry. We were just introduced to the quadratic formula in a different way. And the quadratic formula that they have is that the zeros, the x values, equals h plus or minus this distance that each zero is away from the axis of symmetry. So, and then they give you an expression for d to be the square root of h squared minus c over a. So when you're asked to find the x-intercepts, you have to be able to calculate h. H equals opposite of b over 2a. And so you have to know what a, b, and c are. A equals 1, b equals -4, and c equals -21 in this case. So h is going to be the opposite of b, +4 over 2 times 1 is 2. All right, and then the distance d is equal to, and I should write this here, d equals the square root of h squared minus c over a. So it's going to be h squared, the square root of 2 squared, +2 squared, not that it matters, minus c was -21 over a is 1. So this equals the square root of 4 plus 21, which is the square root of 25, which is 5. Okay, so so the x-intercepts are going to be x1. The first x-intercept will be h minus d is going to be 2 minus 5 is -3. x2, the second x-intercept, is going to be h plus d, and that's going to be 2 plus 5, which equals 7. And so we get 7 and -3 as the two x-intercepts. All right, pretty easy. This came out nice because our distance came out to be a nice simple number of 5 from the quadratic formula given, which tells you, just as a side note, that we could have solved this by factoring, because we would have been looking for two numbers that multiply to -21 add up to -4. And that turns out to be -7 and +3. So we could have written this as x minus 7 times x plus 3, which equals 0, and that gives us 7 and -3, just like we got from the quadratic formula. All right, the next question is not going to be so nice. It says identify the axis of symmetry. Well, that's going to be x equals opposite of b over 2a. So you have to know what a, b, and c are. I'm assuming by now you know that b is going to be 19, so it's -19 over 2 times 3. So it's going to be -19 over 6. And that's the axis of symmetry. Now the distance d is really kind of rough. Okay. That is going to be h squared, okay, which is -19 over 6 squared, minus c over a. C being -14 and a being 3. So this works out to be 19 squared is 361 over 36. So this comes out to be 361 over 36 plus, because minus a -14. Oh, that's not over 1. That's over 3. So that's going to be plus 14 thirds. finding a common denominator of 36. This is going to equal the square root of 36 of 361 plus, now I'm going to put 14 thirds and make it some number over 36. I have to multiply top and bottom by 12. So 14 times 12 is 168. So we got 361 plus 168 over 36. Combine the term. This is ugly. All right. 361 plus 168 gives you 529 over 36. Luckily for us, that's ugly, but luckily for us, 529 is a perfect square. It comes out to be 23. So this equals 23 over 6. All right, what is the horizontal distance? That's the distance, d. Find both intercepts. Well, one intercept, x sub 1, is going to be h, which is negative 19 over 6, plus 2030 over 6. All right, and which equals 4 over 6, because negative 19 plus 23 is 4, which is 2/3. The other x-intercept, I'll call it x sub 2, is going to be negative 19 over 6 minus 23 over 6, which equals negative 42 over 6, which equals negative 7. And those are our two x-intercepts, 2/3 and negative 7, which kind of indicates you could have factored this. But we're not going to get into how you would factor something as ugly as that in this class. All right? So the last one. They want you to find out when 2x squared plus 5x plus 1 equals 0. They're asking for the zeros of this, the roots of that quadratic. So it's the quadratic formula. So first find h. h equals opposite of b over 2a. That's going to be negative 5 over 2 times 2, which is negative 5/4. Then we got to find d. d is going to be equal to the square root of h squared, which is negative 5/4 squared, minus c, which is 1, over a, which is 2. This works out to be the square root of 25/16 minus 1/2 minus 1/2. Sorry about the interruption on my phone. It's getting crazy. It's my family's trying to get a hold of me, I think. So that's the square root of 25/16 minus 8 over 16, which gives us the square root of 17 over 16. And if you calculate that, that's about 1.03, all right, with a calculator. All right, so if we wanted to find the x-intercepts, it would be, the first one would be negative 5/4 minus 1.03. And then the other one would be negative 5/4 plus 1.03. All right, so if you wanted to calculate that, you would get you would get, actually, that would give us the decimal answers. If you wanted the exact answer, we would just say x equals negative 5/4 plus or minus the square root of 17 over 16. Okay? And you could get a decimal answer by plugging into your calculator. And that's it. Thank you. Bye-bye.